Hello, everyone. I wanted to talk about the very first learning target of this unit. In this unit, we talked about properties of matter. There was two types of properties that we used to classify matter. The first one was physical properties, and I'm going to use the unit slides here that we have on your Blackboard account to kind of go over some of the things that we talked about with properties of matter. So the first type of property is physical properties. These physical properties are things that we can observe without actually changing the material. And when we say changing the material, we mean we don't have to break any chemical bonds or make any chemical bonds in order to observe these properties. So, for example, I can observe the color of something without actually changing what it is. I can smell it and observe its odor or taste it. I can even say what phase it is, meaning is it a solid, liquid, or a gas. I can determine its density by using its mass and its volume. I can figure out when it would boil, at what temperature, and when it would freeze, and whether or not it can conduct electricity. And during our labs, we actually did some of these observations. So I gave you three known substances, and you determined all of these physical properties across the top here. What was it, a solid, liquid, or gas? What shape was it? How massive was it? What was its volume? From there, you determined its density, whether it could conduct electricity, and whether it was magnetic. And you actually identified an unknown as one of those three based upon its physical properties alone. And you told me that it was steel that we were looking at, or iron. I believe it was an iron piece that I had this year. Something else that we did in our unit was we looked at chemical properties of matter as well. We said these are properties that you can only observe when you are changing the chemical composition or what that matter is. For example, if I wanted to see if something could burn in fire, I would actually have to take that piece of matter, put it into fire, and if it caught fire, I would say, yes, it's flammable. But as it burns, it's going to be changing what it once was. Bonds are going to be breaking within that substance or even reforming, and I'm going to get a new substance that is created, like the smoke and the ash that'll be coming from whatever that substance is that I'm burning. So I'm going to be changing what it was from its original state. One of the things that we did to kind of cement that idea is we looked at the flame color of certain compounds. So we took a compound of sodium chloride and we stuck it into fire and we ignited that particular compound. Actually, we really excited it and got its electrons and things like that moving. But we determined its flame color was actually a yellowish orange color. And we looked at all the other compounds as well to determine what the chemical property was. Some other chemical properties are, does it react with water or does it react with acid? If you are putting acid on it and it's reacting, then you can't say that you have the same substance you started off originally. When you are looking at the physical properties, some of those properties may change, like the mass or the shape of it, but you're not changing what the substance is, so that's still considered a physical change. If you are changing the substance, like when you're observing a chemical property, that's considered a chemical change. Some of the materials that we looked at and we classified were metals, nonmetals, and metalloids. So we divided all of the matter on the periodic table into three categories. And from there, we said metals have a malleable property, which is a physical property. It's ductile, which is also a physical property. We said it conducts electricity, which is also a physical property. So we said that the properties of metals were that they were good conductors, shiny, ductile, malleable, and that they can be found on the left-hand side of the periodic table. We said even though a lot of people think that metals are all magnetic, there are actually only three that are magnetic. The rest of them, the rest of the 80 some, are actually going to be non-magnetic. And then you have nonmetals. Nonmetals are poor conductors, which means they won't allow a light bulb to light up if you put it in a circuit. They're not ductile or brittle, so they don't like to change shape easily if they're a solid. And so we call them brittle. If they are a solid, we say they have a duller luster, whereas metals had that shinier luster. And actually, many nonmetals are gases. There are no gases in the metallic side of the periodic table, or any elements, I should say, that are considered gases. So all of those are properties, physical and chemical properties of the three main groups of matter: metals, metalloids, and nonmetals. If I look at the questions from our pre-assessment, you can see that we had three questions. The first question said, which of the following terms means that metals can be rolled into thin sheets as in aluminum foil or beaten into complex shapes? Because it says it can be put into flat sheets, that allows me to know that it's malleable. So malleable was the correct answer here. A lot of people chose ductile, but ductile means to be pulled into a wire. Both of them are properties of metals. So that we were able to identify that, but I was actually asking which one can be flattened into a sheet, and that means malleable. Another question that we had about the properties of matter is, in general, which of the following statements about metals is true? The correct answer here is metals are malleable, which means they can be flattened into a sheet. They can be drawn into a wire, which means they are ductile, and they can carry an electric current. And the final question that went along with metals and nonmetals and classifying matter based upon its properties said, which of the following is not a property of most nonmetals? So the correct answer here is they are excellent electrical or conductors. Nonmetals are actually found on the right-hand side, so that is a true statement. If they're solid, they tend to be dull luster and they tend to shatter into pieces, meaning brittle, so that was a true statement. And actually, many of them are gases at room temperature. Being an excellent conductor is actually a property, a physical property of metals. So hopefully this kind of refreshes some of that information that we talked about in the beginning of this unit when we talked about matter being able to be classified or identified based upon its properties.